so we're going to look at rate of change and slope, and this shouldn't be anything that's different to you guys. Rate of change and slope are basically the same thing. So as you're going through this, you should be writing 3.3, rate of change and slope. And we're going to look at these through different ways. Today, we're going to look at them from a graph and a table, where we're going to be able to find the rate of change or slope. They're the same thing, they go hand in hand, given a table or given a graph. So we are going to start by clicking and seeing maybe what is definitely rate of change. Rate of change is a ratio that describes how much one quantity changes with respect to a change in another quantity. Okay? So rate of change is the ratio that describes how much one quantity changes with respect to the change in another quantity. Your rate of change is always listed as change in y over your change in x. One thing to really recognize is rate of change or slope is always y over x. You may also see this written as something like this, and you may think of it as triangle, but it's not triangle. That triangle represents the Greek letter delta. So delta y over delta x. Delta basically means change. So you may see something like this. But the biggest takeaway to get out of this, rate of change is the same thing as slope. And rate of change and slope is always y over x. It's the change in y over the change in x. So if I was given a table, so you should be writing this table into your notes, and I have the number of games, which is my x, and I have the cost. So how much does it cost per game? Let's say you're at like a laser tag place or something. I don't know. Something pretty cool like that. And we want to know our rate of change. We want to know what is the cost per game. All right. And I know a lot of you guys are probably thinking the easier ways, but we're going to set this up and we're going to look at this a little bit differently. We're going to look at our change in y. So we're going to look at our change in y. So how do you get from 78 to 156? Well, to do that, I'm going to add 78. How do I get from 2 to 4? I'm going to add 2. So we have a rate of change of 78 over positive 2. So our change in y was a positive 78. Our change in x was 2. The big thing with rate of change and slope, you always want to simplify. So can I simplify this? Can I basically do 78 divided by 2? And the answer is yes. So my rate of change would actually be 39 over 1, or in this case, it's $39 per one game. Okay. So this is finding your rate of change from a table. You find the difference from one y to the other, and then from one x to the other. Now, some of you may have recognized, well, Mr. Harris, why don't we just take 78 divided by 2 from the beginning? Because that doesn't necessarily always work. We want rate of change. We want to know how we get from one to the next, and the same thing from there so that we can divide. Because also, that leads into what we're going to talk about next, which is to determine if a table is linear. Basically, is it going to have a consistent rate of change? All right. So here's an on your own. Don't worry about this. We're not going to do this one. We're going to move on to this part. Constant rate of changes. Okay, again, talking about our change in y over our change in x. What we want to do here is we want to determine if each table is linear. And how we determine if something is linear, okay, they have the same rate of change every time. So if I go from 6 to 12, what do I get? Well, I add 6. If I go from 12 to 18, how do I get there? I added 6. If I go from 18 to 24, how do I get there? I added 6. Let's match up our x's. How do I go from 1 to 2? I add 1. How do I go from 2 to 3? I add 1. How do I go from 3 to 4? I add 1. So what is the rate of change for each one? Well, this has a rate of change of 6 over 1. This has a rate of change of 6 over 1. And this has a rate of change of 6 over 1. So is this first table linear? The answer is yes. The reason why? It has a constant rate of change of 6. So that's the important part. You're going to have questions that are going to ask you, does this have a constant rate of change, or is this linear? And how you determine it, they have a constant rate of change. Let's look at this one. How do I go from 5 to 1? I subtract 4. How do I go from 1 to -4? Oh, I'm going to subtract 5. And how do I go from -4 to -10? I'm going to subtract 6. Well, so far we're different, but that doesn't necessarily mean it's not going to be linear. How do I get from -10 to -2? I add 8. How do I get from -2 to 6? I add 8. And how do I get from 6 to 14? I also add 8. Now, if we look at each rate of change, this first one has a rate of change of -4 over 8, which is -1/2. The second one has a rate of change of -5 over 8. That does not simplify to 1/2. And this next one has -6 over 8, which simplifies to -3/4. So this one is no, it is not linear because it does not have a constant rate of change. Okay. So to determine if things are linear, they have to have a constant rate of change. Okay, and to do that, you just determine what's the change from every y to every x. So what I want you to do is I want you to try these on your own. So the best thing you should be doing right now is you should be pausing your video and trying this on your own. And I'm going to figure out how to pause my screen recording. This is new to me. I haven't used this program before, so you guys got to bear with me. Maybe. Well, we're just going to do this together, I guess, then, because I can't figure this out. So if we look here, we're going to go +4, +4, +4. This one's -1, -1. Oh, sorry, +1, +1. This one's +2. So we have 4 over 1, 4 over 1, and 4 over 2, which is 2. So this one's no. It does not have a constant rate of change. Let's look at this next one. -4, 1. To get from there, we need to add 5. To get from here, we need to add 5. To get from here, we need to add 10. Well, let's look here. We need -3, -3, -6. We have different numbers, but let's take a look. This first one, this constant rate of change is 5 over -3. This one's 5 over -3. And this one is 10 over -6. But if I simplify 10 over -6, I get 5 over -3. So yes, because it has a constant rate of change of -5/3. Okay, so even though these are different, they simplify to be the same. So that is why this has a constant rate of change. All right, so this is asking me if I'm still here. Stay in the call. Okay, good. So we just did that. Okay, so to determine if something's linear, we want to make sure they have a constant rate of change. How do we determine if they have a constant rate of change? We make sure there is a consistent change through each part. Okay. And just like we did here, just draw your little loops. All right, constant rate of change, as I mentioned, is the same thing as slope. Slope goes into graphs. Oh, I went too far. Right? with slope, there are 4 different types of slope. We can either A, have a positive slope, or B, we can have a negative slope. We'll talk about C and D later. A positive slope, it goes up from left to right, and a negative slope goes down from left to right. So if this is the left side, this is the right side. Start at the left, this is going down. If this is the left side and this is the right side, starting from left to right, this is going up. Okay? Positive slopes from left to right go up. Negative slopes from left to right go down. What are the other 2 types of slope? The other 2 types of slopes are undefined slopes. These are vertical lines. So any vertical line has an undefined slope. And then the other type of slope is a 0 slope, and this is a horizontal line. Okay. So undefined slope, vertical lines, horizontal line is a 0 slope. There's a difference. All right, so how can we calculate slope of a line? When we're given a graph, we can calculate the slope by calculating what's called our rise over run. Okay. The other thing you need to add in here, slope has a variable. That variable is m. That's important. I'll go over when I'm back in class where they get the variable m for. All right, it's a fun little tangent I like to go on. So if we look at this first graph, I always like to start at my furthest left point. And so this is my furthest left point. And I want to calculate my rise. I want to figure out how far up or down I need to go to get even with the next point. So I need to go up 1, 2. Now I'm even. Then I need to go over 1, 2, 3. Now I hit the point. So my slope is a rise of 2 and a run of 3. Now, before I pause, let's just double check. Is this slope supposed to be positive or negative? Well, from left to right, so this is the left, this is the right, this line is going up. Since it's going up, it should be a positive slope. Look at this one. Well, this graph looks a little weird because I'm only given 1 point. Well, how do I find that other point? Well, if I look like this right here, that's not a good point. That doesn't hit it. That's not a good point. This right here is a good point. Okay? That right there is a good point because it hits an intersection. So if you're not given a point or you're only given 1 point, you can find other points by finding where the line crosses through another point. So this is my furthest left point. I need to figure out my rise, whether I need to go up or down to hit my next point. Well, I need to go down. So I'm going to go 1, 2, 3, 4. I went down 4, and then I need to hit my point. I'm going to go over 1. And as you see, I didn't write positive or negatives. My rise was 4. My run was 1. I put it as 4 over 1. Now let's look. From left to right, what does my line do? It goes down, so my slope should be negative. So m equals negative 4 over 1. Okay. One of the big things is you really have to remember to simplify slopes. So let's say I had a slope on the left one, it was 4 over 6. I would simplify it to 2 over 3. Always simplify slopes. What happened here? Oh, let's do another one. Let's calculate the slope. All right, let's start at our furthest left point. Well, my next point's down here, so we're going to go 1, 2, 3, 4, 5, 6. Went down 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So I had a rise of 6 and a run of 10, which again, here's one of those ones where you can simplify. 6 and 10 are both divisible by 2. So we get 3 over 5, m equals 3/5. All right, and if I did 3/5, if I went, let's choose a different color. If I start at this point, I went 1, 2, 3, 1, 2, 3, 4, 5. I actually hit a point that's on the line. So this next one. Oh, wait, we're not done. We missed something. This line from left to right, it goes down. So our slope needs to be negative. Doesn't matter where you put the negative. You want to put it on the numerator, you put it on the numerator. You want to put it on the denominator, you put it on the denominator. If you want to put it in front, you can put it in front. I'll go over that when I get home, or get back about the wheres and whys. Look at the slope on this one. Start at our furthest left point. 1, 2, 3, 4, 5, 6. We went up 6. 1, 2, 3, 4, 5, 6. We went up 6. So we had a rise of 6 and a run of 6. Well, what is 6/6? That's just 1. So we have a slope of 1. And from left to right, it went up, so it's positive. So if I look, I can go up 1/1, up 1/1, up 1/1, and every time I hit a point on the line. Okay? So that's how you calculate slope from a graph. You just do the rise over the run. All right? Make sure you check from left to right. If it goes down, it should be a negative slope. Okay? If from left to right it goes up, it's a positive slope. Make sure you remember vertical lines are an undefined slope. Horizontal lines are a 0 slope. Good. Hopefully that helped out. All right, now that you're done with this video, you should be working on your practice.